Hello students and welcome to this series of linked list. As we know that in previous lecture we have discussed the basic concept of list. Again we have discussed how linked list is created, what is use of start pointer, then what is node, what are the different types of what are different parts of nodes, that is info and link. Again we have also discussed the memory representation of linked list. Now in this video lecture we are going to discuss what are the different operations are there in linked list. Basically in case of linked list, insertion, deletion, then traversing, these are the three basic operations are there. Okay, well, first one is simple: insertion, deletion and traversing. These are the basic operations are there. Again different operations are also there, that is for display the elements of linked list, then concatenate two linked lists. So the different operations are also there in linked list. So as of now we'll start with one of the operation from the linked list, that is traversing. So we'll discuss the traversing operation in linked list. We'll discuss traversing operation in linked list. Traversing in linked list. So what is traversing? We know that insertion means simple, we have to insert one element. Deletion means we have to delete one element from linked list. Now what is mean by traversing, or what is definition of traversing? Simple, traversing, we can call it as a traversing. It is a process of going through all the nodes of linked list from one end to another end. Okay, simple, it is a processing of all the nodes from one end to another end. This is nothing but traversing. So we are travel from first node to last node. Simple. This is a basic definition of traversing. Suppose if we start from very first node to the last node, we start from first node to last node, then such type of traversing is called as forward traversing. Okay, so what is forward traversing? If we start from first node, very first node, and we start traversing from first to second, third up to the last node, then this type of traversing is called as forward traversing. So this is a basic definition of traversing. So I will dictate again. So traversing, it is a process of going through all the nodes of linked list from one end to another end. This is a simple definition of traversing. So in case of traversing, we require a list, that is we require a linked list which has different n number of nodes, and each node has info part and link part. Again we require one pointer which is called as start, which hold the address of our first node. Simple. So let's discuss this traversing. Again one more thing is that along with this start pointer, here we require one more pointer, that is as of now we consider we give name as a PTR. That PTR, in case of traversing algorithm, okay, we require one pointer variable PTR, and that PTR actually points to the node that is currently being processed. Okay, so I will draw the simple linked list so you will easily understand the concept. So here I will draw one simple linked list. We'll discuss the concept of traversing. So this is first we required pointer variable start, which actually hold the address of first node. Okay, total 3 elements are there. So now consider, for our simplicity I have taken these addresses 100, 200 and 300. Addresses may be anything. Okay, so positive number should be there. So this is the address of this node. 200 is the address of this node. 300 is the address of this node. So start will hold the address of first node. First node address of first node is 100. So start will hold the 100. A will hold the address of, this is the info part. This is the link part. Again same for all, info, link, info and link. So this info part of first node contain A. Link part will hold the address of next node. That is, next node is this node. An address of that node is 200. So 200 will get stored over here. Same 300 will get stored over here, address of next node. And after this 300, no node is there. So this is the last element. So simply we'll put 0 over here, or 0, or we can call it as a null. We simply put null over here. Now suppose we have to apply the traversing operation on this linked list. So as I said, in case of traversing, we required one variable, or not variable, we require one pointer variable, and we called it as a PTR. Okay, what PTR is used for? Basically PTR, it is used to hold the address of the node which is currently being processed. What PTR hold? Or it points to the node which is currently being processed. So simple. So I will write over here. PTR points to the node this, or that is points to the node that is currently being processed. Now, how to travel this linked list? Okay, so first step in this case, what we have to do, we have to first initialize this PTR. First we have to initialize. With the help of PTR, we have to travel this linked list. Okay, so I will explain this traversing method with the help of algorithm. So first I will write the algorithm, and simultaneously we will discuss this operation. So first of all I will write the algorithm. So what is meant by algorithm? That we have already discussed in a chapter of stack queue, right? So same algorithm is over here. So first step, first we have to set second step I hope it is visible to you. Okay, so this is a algorithm I have written. This is the algorithm to traverse a linked list. So we are having a linked list with us. We are having algorithm, and we are having the pointer variable, which points to the node which is currently being processed. So let's discuss the traversing concept with the help of this algorithm. So first step, these are the steps. Okay, so total 5 steps are there. So in first step, what we have done, as we have already discussed the definition, what is traversing? Traversing means simply it is a process of going through all the nodes in a linked list from one end to another end. So it is simple, going from one end to another end. It is nothing but traversing. So let's start the algorithm. So here, what is first step? First step, set ptr is equals to start. So here, what is ptr? Ptr, it is a pointer which points to the node which is currently being processed. So we have to start from this node. From first node to last node we have to travel. So we have to start from first node. So first node or address of first node we have to assign to this ptr. And where that address is stored, the address of first node is gets stored in the start. So because of that, to get the address of first node, we have done ptr is equals to start. So I will write over here. Okay. Now first step, we'll get ptr is equals to start. The value of start is equals to 100. So ptr will store the value 100. Now in this case, value of ptr is equals to 100. This is we can call it as a initialization. Okay, so we have initialized ptr to 100. Next, what is the next step? Repeat step 3 and 4 while ptr is not equals to null. Okay, why I have written this while ptr is not equals to null, this condition? Because we have to travel till the last node. When the value of ptr, what actually ptr hold? Ptr hold the address of node which is currently being processed. First time it will hold address of this, then this, then this, and at this end we have to stop. So for that we have set ptr is equals to null. So as we process step by step, we'll easily come to know why we have set this. So now, as of now, just consider when value of ptr becomes 0, we have to stop. Okay. So after that, after initialization, we have to repeat step 3 and 4 while ptr is not equals to null. Though as of now, value of ptr is equals to 100. So it is not equals to null. Ptr is not equals to null. So condition is true. When condition is true, we have to repeat step 3 and 4. So what is step 3? Apply process to info of ptr. This is a info part and this is a link part. So here, info of ptr, as we have already discussed this info, this is an array, right? This is of one array and this is a second array. Info of ptr, that is value of ptr is equals to 100, means info of 100. This is a 100 address, 100 over here, and info of this, info of 100 is a, right? So value of this we get is a. So we have to apply process on info of ptr. Process may be anything. Whatever process you want to perform, you can perform. If you want to display, you can display this value a. It depends on you. So we can apply any process. So I have written this general word process. Apply process to info of ptr. So after that process, suppose if you want to as of now consider if you want to write the info. So instead of process we can use the word write info ptr. What it will do, it will simply display the value a. Okay, so after applying the process, what we have to do, so whatever process we have to apply on this info we have applied. Then what next we have to do, we have to traverse from after a, we have to move towards the next node, then we have to move towards the third node. So after a, we have to move towards the next node. So where we'll get the address of this next node, we have stored the address of this node, this next node in the link part of this. So that's why what we have done, set ptr is equals to link of ptr. Okay, link of ptr. Okay, I will write over here. Link of ptr, value of ptr is equals to 100. So link of 100. As we have get the value a, link info of 100 we get a. Similarly, link of 100. This is a link part. Right. So this is a link part. Link of 100 we get 200. And we have stored this 200 in ptr. So ptr becomes 200. That is, initially ptr was pointing to this 100. That is, initially ptr was pointing to this node. But after this process, now ptr we have stored value of ptr is equals to 200. So instead of pointing to this node, now ptr will point to this second node. Okay, again after this, again our control, we have to repeat this 3 and 4th step till ptr is not equals to null. Again value of ptr is equals to 200, it is not equal to null, so our control will move towards this condition again. Again the condition will get checked. So ptr is equals to 200, 200 is not equals to null. Yes, 200 is not equals to null, condition is true. Again our if condition is true, we have to again repeat these steps 3 and 4. Again apply process on info of ptr. So info of ptr, value of ptr is equals to 200. So info of 200, this is a 200 and info of this is b. So info of 200 is b. Again we have to apply the process, whatever process you want to apply you can apply. As of for an example I have written the write. It will simply display that info of ptr. So it will display b. After the applying process on info of ptr, next step is set ptr is equals to link of ptr. Again same. What is link of ptr? This is a ptr pointing to 200 and in the link part of that 200 we are having this 300. So again link of 200, what we get, link of 200 we are having 300 stored over here, so it will give 300 and we have assigned this 300 to ptr. So value of ptr becomes 300. So after this step again we have to move towards the second number step. Again we have to check whether value of ptr is not equals to null. Yes, it is 300. It means it is not equals to null, condition is true. Again we have to come inside this while loop. We have to again repeat the steps 3 and 4. Again we have to apply process on info of ptr. So info of ptr, value of ptr is equals to 300 and info part of this 300 contain this c. So c, we apply process, we write this c, we'll get c displayed on screen. So after processing, what next? Next is set ptr is equals to link of ptr. Again ptr is equals to 300, link of 300. This is a 300 and link part of this 300 contains 0. We'll get 0, that is null. So after that, after processing this step, what we have to do, again we have to jump towards the second step. What is second step? ptr is equals to null. ptr is not equals to null. So here value of ptr we got 0. right? Because link of PTR, value of PTR is previously value of PTR was 300, right? So link of 300, what is the link of 300? Link of 300 is 0. So instead of pointer pointing towards the 300th node, it will point to the node with the 0 address, means it will contain the null pointer. So here value of pointer becomes 0. So PTR is equals to 0. 0 is not equals to null. Null is not equals to null. No, it is equals to null. So condition false. So condition false, it will directly jump, instead of executing third and fourth step, it will directly jump towards the fifth step and it will stop. Okay. So I think now after execution all the steps, you come to know why we have written this condition while PTR is not equals to null. Okay. So till PTR is not equals to null, we have to travel each node from first node to last node. Okay. When the value of PTR becomes 0, we have to stop, because PTR will hold the address of node which is currently being processed. After this, we are not having any node, so that PTR will hold the address 0, and that time we have to stop. So that's why we have used this condition, PTR is equals to, PTR is not equals to 0. Okay, I hope you understand how to travel. So just take a quick review that what we have discussed now. So here initially we have draw one linked list with the 3 elements. Then here we required one pointer variable PTR, and that PTR actually hold, or it points to the node that is currently being processed. So here I have written one algorithm. So first we have to set PTR is equals to start hold the address of first node. So traversing, in this case we have to travel from first node to last node. So first we have to get the address of first node which is stored in start. So we have initialized this start is equals to PTR. So PTR will point to this first node. Then after that we have written the condition, we have to repeat step 3 and 4 while PTR is not equals to null. Then when it is not equals to null, we have to first process this info part, and after that after processing we have to move towards the next node. So how we are going to move towards the next node? By simply using this instruction link of PTR. Link of PTR will contain the address of next node that we have to assign to PTR. Here we have done the same process. Then same process will get repeated while PTR is not equals to null. Once the PTR is equals to null, that is once we reach to the last node, we have to stop. Okay, I hope you understand this concept of traversing in linked list. In the next lecture, we'll discuss another different operations related to the linked list. We'll stop over here. Thank you.